Let's see the next question. Discuss all point of discontinuity. Here we are asked to discuss on the points of discontinuity. The function f of x is given by mod x plus 3 if x is less than or equal to negative 3, minus 2x if minus 3 less than x less than 3, 2x plus 2 if x is greater than or equal to 3. So, let's see this function once again, because there is a mod x. Actually, when you take a mod x for the value of x less than or equal to negative 3, mod x will give you positive x or negative x. Just think about it. For the values of x less than or equal to negative 3, mod x is equal to what? Negative x. So, I can rewrite this function as negative x plus 3, because mod is only for x, not for the entire x plus 3. So, minus x plus 3 if x is less than or equal to negative 3, minus of 2x if negative 3 less than x less than 3, 6x plus 2 if x is greater than or equal to 3. So, the only change that is happening, what I have discussed now is mod x is now becoming negative of x as x is less than or equal to 3. Okay, now let me draw our number line. And I have for the values of x, here I have negative 3, then the next value is 3. Right? For the values of x, the function f of x, for the values of x less than or equal to negative 3, the function is minus of x plus 3. For any value that lie here on this number line up till negative 3. Right? Negative 3 is not included. Up till negative 3, less than negative 3, the function value is minus x plus 3. Okay. In between minus 3 and 3, the function value is minus of 2x. And for all values of x greater than 3, the function is 6x plus 2. 6x plus 2. Now let's see it in detail. Now to discuss the continuity here for all values of x less than negative 3, I will take an arbitrary value here in this interval. Right? So, when I am discussing x is lesser than negative 3. For the values of x less than negative 3, let c be any arbitrary value. As I discussed earlier, arbitrary value means what? Arbitrary value means what? It is any value, not specific value. There is no specific value there, but there is any value that is lying lesser than negative 3. So, C be any arbitrary value. Then, limit x tends to c f of x is equal to what? I need to check for limit x tends to c as well as f of c also. Okay. What is the function's value for x? Limit x tends to c. Here, anywhere over here, the function is minus x plus 3. Minus x plus 3. That is minus c plus 3. As the value of x tends to c, it is minus c plus 3. Now, what is f of c there? Here, it is again minus 3 plus minus c plus 3. What does this imply? This implies f is continuous. For what? Continuous for all values of x less than negative 3. Now, discussing for x is equal to negative 3. Next point is where? Negative 3. So, when I discuss on negative 3, what is the importance there of negative 3? On the left of negative 3, on the right of negative 3, functions are two different values, isn't it? So, I have limit x tends to minus 3 minus. What does that mean? The function is moving, the value of x is moving to negative 3 from the left hand side. Minus 3 minus. Minus 3 minus of f of x. This is equal to limit x tends to minus 3 minus. What is the function on the left of minus 3 minus means what? Lesser than minus 3, right? That is minus of x plus 3. What do I get? In the place of x, I'll substitute minus 3, right? That is this minus of minus 3 plus 3, which is equal to 6. Right? Now, moving on to the next part, limit x tends to 3 plus negative 3 plus f of x. The function is attaining, or the values of x is moving to negative 3 from the right hand side. So, this is equal to limit x tends to minus 3 plus of. What is from the right hand side means, what is the function there? Minus 2 into x. What is the value? Minus 2 into negative 3, which is equal to 6 again. Right? Minus 2. X value is what? Negative 3. Right? So, negative 3, it is 6. Now, what about f of negative 3? Now, see, when the value of x is negative 3, the function value is what? Minus of negative 3 plus 3. X is minus, this function value is minus x plus 3. Minus of x is minus 3 plus 3, which is again equal to 6. So what does this implies to? Therefore, f is continuous at x is equal to what? Negative 3. Right? Now, when I consider this entire interval, again I need to discuss on this interval. That means, in the interval where minus 3 less than x less than 3. This is the next interval. Inside this interval, how do I conclude about, what do I say about the discontinuity? Let I take a point C. C be any arbitrary value. Right? Arbitrary value. Then, can't you say limit x tends to C minus, right? Minus C minus f of x. That is, the C is any value inside this interval. If the value approaches from this side or from this side, the function value is the same. Right? So, I will readily write this is equal to limit x tends to C minus, what is the f of x function? Minus of 2x, which is equal to minus of 2c. Similarly, limit x tends to C plus f of x, which is equal to limit x tends to C plus. C is where? Inside this interval, don't forget that. Of f of x, function value is 2x, which is again equal to minus of 2c. What is f of c there? F of c is equal to minus of 2c. Therefore, f is continuous. Where? Continuous where minus 3 less than x less than 3. In the interval minus 3 less than x less than 3. Now I am discussing on 3. Right? Discussing on 3. I shall just write it over here. Okay. When I discuss on the function, the value x is equal to, the value I am discussing on the continuity at x is equal to 3. Now, on the left of 3 and on the right of 3, the function values are two different values. So, I need to check for both the limits. So, I have limit x tends to 3 plus f of x. What does this mean? The function is reaching or moving to 3 from the right hand side. That is limit x tends to 3 plus of 6x plus 2. That is 6 into 3 plus 2. That is what? 20. Right? Now I move on to limit x tends to 3 minus f of x. This is equal to limit x tends to 3 minus. 3 minus means what? Lesser than 3, isn't it? That is minus 2x, which is equal to minus 2 into 3, which is minus of 6. So, what can you say from here? Limit x tends to 3 plus f of x not equal to limit x tends to 3 minus f of x. So, what is the question? Discuss all point of discontinuity. What did you get? At the point where x is equal to 3. See, x is equal to 3, the function is discontinuous. Elsewhere, the function is continuous. But here we have didn't discuss about the values of x greater than 3. This part I am giving it to you as a homework. The x is greater than 3 means what? For any arbitrary value c that belongs to here. As we have proved it here, for any arbitrary value c that belongs to this particular interval, similarly you will prove it for x greater than 3. What can you say about the discontinuity? Will it be continuous or discontinuous? For any arbitrary value of c that lies here, the function is going to be continuous. So the only point of discontinuity is where x is equal to 3. Okay? So I hope this is clear. Let us move on to the question number 8. Find a relationship between a and b so that f defined by f of x is given by ax plus 1 if x is lesser than or equal to 3, bx plus c if x is, this is b, bx plus c if x is greater than 3 is continuous at x is equal to 3. So what is given? This is continuous at x is equal to 3. If it is continuous at x is equal to 3, then limit x tends to 3 plus f of x, which will be equal to what? Limit x tends to 3 minus f of x, which will be equal to f of 3. Isn't it or not? If it is continuous at x is equal to 3, then this is true. This statement is true. Let's see. Limit x tends to 3 plus f of x. What is the value? Limit x tends to 3 plus. 3 plus means what? Greater than 3. Bx plus 3, which is that, which is give you 3, x value is going to be 3. 3b plus 3, right? 3b plus 3. Limit x tends to 3 minus f of x. What is the value that is going to come here? Limit x tends to 3 minus, lesser than 3, that is ax plus 1. What is the value? 3a plus 1. Now, what is f of 3? F of 3 is what? When I substitute it here, that is 3a plus 1. Now, looking into this statement, that is this statement, I am going to just substitute. I am asked to find the relationship between. I am just going to substitute it over here, this and this. That is, which implies 3b plus 3 is equal to 3a plus 1. Right? Which implies 3a minus 3b, I have brought 3b to this side, minus 3b is 3 minus 1. 3 minus 1, I have brought minus 1 this side. That is 3 times a minus b is equal to 2, or a minus b is equal to 2 by 3. This is the required equation. I hope it is clear. Now, let's come to the next question. For what value of lambda is the function defined by f of x is equal to lambda into x square minus 2x if x is less than or equal to 0 and 4x plus 1 if x is greater than 0 is continuous at x is equal to 0. So that is the first part of the question. What about the continuity at x is equal to 1? We shall discuss the second part later. See the first part. What is it said? For what value of lambda is this function continuous at x is equal to 0? That is, the function is said to be continuous at x is equal to 0. Right? And for what value of lambda is the question. So if the function is continuous at x is equal to 0, then limit x tends to 0 plus f of x is equal to limit x tends to 0 minus f of x is equal to f of 0. Isn't it or not? Yes. So now let me see what is limit x tends to 0 plus f of x. This is equal to limit x tends to 0 plus of, when the value of x is greater than 0, the value of the function is 4x plus 1. On substituting the limit, what will I get? I will get it as 1. When x is equal to 0, 4 into 0 plus 1 is 1. Okay. Now coming to the left hand limit, 0 minus f of x. This is equal to limit x tends to 0 minus. What is the value? Lambda into x square minus 2x. Isn't it or not? So, when I substitute for x is equal to 0, I get this value as 0 because 0 minus 0 is 0. 0 into lambda is 0. Now from these two cases, I get a contradiction. Why? Because limit x tends to 0 plus f of x is equal to limit x tends to 0 minus f of x as what? As it is continuous, as it is given in the question. It is given in the question that it is continuous, right? So this is equal to this. This implies, what about this value? 1. What about this value? 0. Now we have got it as 1 is equal to 0. Isn't this a contradiction? Yes. So this means it is not possible. This particular relation is not possible. This limit doesn't exist, right? 1 is having 0, 1 is having 1, right? So 1 is not equal to 0. If the limit exists, these two must be equal, but I cannot say these two are equal, which is a contradiction. Therefore, what can I say? It is asked in the question, for what value of lambda there exists no value for lambda such that it is continuous at x is equal to 0. That means the function is not continuous for any value of lambda. Now it is asked, what about the continuity at x? Now see, this is the point 0. Towards this side you have the function as lambda into x square minus 2x. Towards this side you have the function as 4x plus 1. Right? Now here, when you have, or when you are checking for the continuity at 1, right, this is 1. On the left of 1 the function is the same, on the right of 1 the function is the same. That is 4x plus 1, that is on the left. That gives you 4 into 1 plus 1, that is 5. On the right hand side, what will you have? 4 into 1 plus 1. So that is also 5. At 1 also you will get it as 5. So that part I am giving it to you to check for the continuity. That is to check for limit x tends to 1 plus f of x is equal to limit x tends to 1 minus f of x is equal to f of 1. So this is what you need to check to complete the question. This part I am giving it to you. You can check and you can very well say that the function is continuous at x is equal to 1. Okay? Okay. So, now let's see what is the greater integer value that I am going to get. Suppose, what is x minus h? From the greater integer, I am subtracting a value h. So, if I am subtracting a smaller value, the lesser integer, suppose from 2, I am subtracting 0.1. What will I get? What will I get? 1.9. Isn't it? Which is the smaller integer here? 1. Right? Now from here, x minus h. When I subtract a smaller integer from this, I will get x minus 1. X minus 1. Whereas the greater integer value of x plus h will be what? X. Because if I look at, this is same as 2 plus 0.1. 2 plus 0.1 is 2.1. 2.1 means the smallest integer there is what? 2. So here x plus h, the smallest integer is x. X minus h, the smallest integer is x minus h. I hope this is clear to you. Okay. Now let us come back to the question. Yes, so limit, we are asked to check for what? Now, we are asked to check for the continuity of the function, to show that the function is discontinuous. So, we are asked to check for the continuity and we will see that it is discontinuous. So, limit x tends to a plus f of x is equal to limit x tends to a minus f of x is equal to f of a. This is what? This is the condition for continuity which I am going to check now. So, let me check for the right hand limit. Limit x tends to a plus f of x. This is equal to limit x tends to a plus of x minus greater integer value of x. right? Now when I substitute a here, what will I get? A. Right, when I substitute a here, I will get it as a. Now, what about x, greater integer x, a plus h. A plus h gives you what? A again. So this becomes a minus a, which is equal to 0. Am I clear, children? Okay, that is because the greater integer value a plus h is what? A smaller integer, a plus small value. When I add a small value, what will I get? The greater integer means what? It is less than or equal to x. So x, when I add a little bit more to x, that is 2. If it was 2 plus 0.1, 2.01, right? So what will I get the smaller integer as 2? So here a plus h, that is a. So a minus a is equal to 0. Now limit x tends to a minus f of x. This is equal to limit x tends to a minus x minus greater integer value of x. Right? So what do I get? This x is a itself, a minus, from here when I subtract a value, it comes to the next one, that is 2 minus 0.1, that is 1.9. So 2 minus 0.1, that is 1.9. 1.9 means 1 is the smaller integer there. That means 1 reduced to this, that is a minus 1. That gives you a minus a plus 1, which is equal to 1. A and minus a cancels, so gives you 1. Here I see that limit x tends to a plus f of x is not equal to limit x tends to a minus f of x. So that the function f is, the function given is not continuous or is discontinuous at all integral points of x. Right? So here I have taken a. On all other cases I have taken it as c. Here also you can take it as c. So when you do, try with c. What is c? C is any arbitrary constant in the domain of the function. C can, here it is not specified, any interval is not specified. So here a, if I have to define a, I will write here a is any arbitrary value that is defined in the domain of the function. When you write about c, everywhere this a get replaced with c, that's all. But what is c? C is the arbitrary constant in the domain of the function. Am I clear? Well, we come to the next question. Find all points of discontinuity of f where f of x is equal to sin x by x if x is less than 0 and x plus 1 if x is greater than or equal to 0. So, as we had discussed in the previous question, it is again to check for the discontinuity or it is to check for the continuity, whichever way. Since the question is to check for the discontinuity or continuity, we will check for continuity, and those points which are not continuous, we will say that it is discontinuous. So, for all points of discontinuity, to check for all points of discontinuity, I will check for limit x tends to 0 plus f of x, whether it is equal to limit x tends to 0 minus f of x, which is equal to f of 0. Now I am going to check only for this. Why am I checking only for this? Why am I checking only for this? It is because, see, for any value, any arbitrary value c that lies lesser than x is equal to 0. That means here, as I have drawn for the former one, this is 0. For any arbitrary value c that lies here, the function is the same, right? Which we have already discussed how for any value c, the left hand limit and the right hand limit of c is going to be the same because of the same function. As well as this side, for any value, any arbitrary value c that lies towards the right hand side, c is over here. The value of c the value of the function approaches c from both left and right. The function is the same. Got it? So it is very much evident that for all values lesser than c and all values, for all values lesser than x and all values greater than 0, lesser than 0 and greater than 0, it is said to be continuous, or we can see that it is continuous. As we have done in the former questions, you can write what? For all x lesser than 0 and x greater than 0, right? The function is what? Continuous. If you want, you can prove it also, like what I have proved in the earlier questions. Or else if you write like this is also fine. What we need to check for is this. So now, limit x tends to 0 plus f of x, which is equal to limit x tends to 0 plus more than x is more than 0 is x plus 1. When I substitute, what will I get? X. This limit is equal to 1. Now checking for limit x tends to 0 minus f of x. This is equal to limit x tends to 0 minus. When the value of the function is lesser than 0, it is sin x by x. Isn't it? Sin x by x. Now, as the value of x tends to 0, what is the value of sin x by x? We know that the limit of x tending to 0 sin x by x is equal to what? 1. Isn't it? So here in this function you will get this as 1. So what do you see? Limit x tends to 0 plus f of x. Now one more thing is there, isn't it? We need to check for f of 0. What is f of 0? When I substitute x is equal to 0 is this, f of 0 is 0 plus 1, which is again equal to 1. So limit x tends to 0 plus f of x is equal to limit x tends to 0 minus f of x, which is equal to f of 0. So as we have discussed, for all values of x less than 0 the function is continuous, greater than 0 the function is continuous, and at x is equal to 0 also the function is continuous. So what can you say to the conclusion of this question? Is there any point of discontinuity? No. There is no point of discontinuity. So we will conclude that the function is continuous throughout its domain, or there is no point of discontinuity. Okay. Now come to the next question. Determine if f defined by f of x is equal to this is continuous or not. So here it is said that the function f of x is equal to x square into sine of 1 by x. Sine of 1 by x where x is not equal to 0. Where x is not equal to 0. So let's see. Here what we need to check is limit x tends to 0 f of x. Because 0 plus f of x and 0 minus f of x, the function's value is the same. So limit x tends to 0 f of x is equal to limit x tends to 0 of x square sine 1 by x. X square sine 1 by x. Now x square sine 1 by x. What does this mean? As a value, see the sine value, sine 1 by x lies between where and where? Lies between minus 1 and 1. Isn't it? Sine value lies between minus 1 and 1. Now you have an x square. As the value of x tends to 0, what will happen to this function? What will happen to this function? This function will, this sin x will never be equal to 0 because 1 by 0. Right? So 1 by 0 does not exist. So the values of this value will never be 0, or sin x lies between minus 1 and 1. Here x square into whatever be the value of sin x, what am I going to get the limit value as? 0. Isn't it? So the sine value lies between minus 1 and 1. And you have an x square here. This x square, as x tends to 0, this x square tends to where? 0. Right? So 0 into this value will give you always what? 0. 0 into anything is giving you 0. So now f of 0. What is f of 0? X is equal to 0, right? F of 0 is also equal to 0. So what will I say? Limit x tends to 0 f of x is equal to f of 0. Therefore the function is continuous. The function is continuous at x is equal to